Hello friends, in this video I will discuss the ANSYS Fluent modeling of laminar flow in a pipe. So this is our problem. The diameter of pipe is 40 millimeter and its length is 100 millimeter. The inlet velocity of water we will be selecting as 0.00025 meter per second, and the fluid exhaust into the ambient atmosphere, as you can see in this image, and the density of water is 1000 kilogram per meter cube. So this should be the computational drawing in Fluent. So in Fluent, the y direction we will be selecting R, and in x direction we will be selecting Z. And these are our boundary conditions. So at the walls, velocity should be 0, and this we will be select as axis, and here we should allow the outlet, while at the inlet the velocity should be in the z direction. So we will going to solve this problem in Fluent. For that, first we will open the ANSYS workbench. This is the student version of the ANSYS, and now we will go to the systems and we will select Fluent and just pull it here. So now first we will click on the geometry, then we will right click, and then we will select the new design modeler geometry. So it will take around 1 minute for its opening. So now the design modeler is opened. So since we have to make the 2D geometry, then we will click on this Z. Now the geometry will be, now you will see in this window X and Y. So now we click on the XY plane. So now you can see here, this is the X direction and this is the Y direction. Now we will click on sketching and we will select the rectangle. Okay. Now take the cursor towards the center. So when you see P, so then you will click, so it will select the center and just draw it. Okay. Now go to the dimensions and select horizontal. Click on this center, then click on the outer edge. So this will give you the horizontal direction. Similarly, click on vertical, click on the center line, click on this line, and this will give you the vertical dimensions. Okay. So now our horizontal dimension, as we know, is 100. Okay. And our vertical direction is, because our diameter is 40, so that should be 20. Okay. So this is, now if we want to see the full figure, then we will click on the top, zoom to fit. Okay. Now one more thing, because we have selected the dimensions in mm, so we have to make it 0.1, and here is 0.02. Okay. So now that's the diameter in millimeter. So again, now you have to zoom it if you want to see the full geometry. Okay. So this is how our geometry looks like. So now we are done with the geometry. Then we will click on the modeling. Click here on this, select the sketch and click generate. Okay, so now this geometry is generated. Now we will have to make a surface. For that we will go to concept, and we will click surface from sketches. Okay, we will select our surface and apply here, and then simply click the generate. So this will generate the surface. So this completes the geometry part. Now either we can close it or we can simply go to the workbench. So I'm closing it. Okay, so here you see the right, that means your geometry part is over. Now we will double click on the mesh so that we can generate the mesh, and this will open up the meshing part of the design modular. So it will also take some time. So let us wait for the same. So now our meshing module is open. So this is our geometry. So again we can click on the Z. So it's just opening up. So now you can see the geometry. So first we will name the parts. So for that we will click on the edge selector, then select this, right click and select the create named selection. So this is your inlet. So type the inlet, click OK, then select this, right click, then this is your outlet. Okay, then again select the bottom one. So this is the axis. So just axis AXIS. Okay, and then top one is the wall. So this is wall. Okay, so when you click on the plus sign behind the named selection, then you will see all the parts: inlet, outlet, axis, and wall. Okay, now we have to generate the mesh. So you can generate the default mesh by just clicking on the generate, but that mesh is quite coarse and we have to generate a slightly finer mesh so that we can obtain good results. Now for that, what I will do, I will click on the mesh, then right click, then insert, and then go to the sizing. Okay, now I will select both the opposite edges and apply here, and here I will select the number of divisions, say 25, and behavior I have to select as hard. Okay, again I go to the mesh, insert sizing. Okay, then again I will select the edges, opposite edges, click apply, again select the number of divisions, say 100, again change the behavior to hard, and then click on the generate mesh. Let us see the generated mesh, how it looks. So again the mesh is very good, but slightly coarse at the middle. If you want a uniform mesh, then what you can do, simply click on the mesh, insert, method, and then select the surface, apply. Okay, and now go to the method again and select the monthly zone. Okay, and click on the generate. And now you can see the rectangular type of mesh. So this is how you can generate the mesh. So the now mesh part is also over. We will close this one also. So as you see, there is no right here. So what we can do, we can click on the right click and just click on the update. So then you will see right after some seconds. It is just updating. Again, just click the update so that it can be updated. So it is just updating. Now the right is come up here. So that means the mesh is updated. Now just click on the setup. Now you can select the number of processors. So since our problem is simple, so we will keep it one. Otherwise, if you are having a very fine mesh and number of nodes are very high, then you can also select multiple processors. So let us start. So this will open up the Fluent file. So now this is opened up. Now we will move from top to the bottom. Okay. So first we will select the Axisymmetric because we have an axis. And if we want transient analysis, then we can select transient. So at present we are doing a steady, so a steady is enough for us. Then we can check the mesh also, so that's okay here. Then we will go to the models. Okay, so since our flow is laminar, so we will go to the viscous and click on laminar, then click on OK. So we do not need other options. So this selection is over. Now we will go to the materials. Now by default, they have selected the air, but we need water. So what we can do, we can double click here and can go to the Fluent database, and when you pull it down, you can see water liquid. So just click on water liquid and click on copy. So now this water liquid is copied. Okay, now we put the density as 1000, or we can take the default value also and we just change it and close it. So now water liquid is there. Okay, now we go to cell zone conditions, select the surface body, edit it, and we will select the water liquid, apply. So now in this zone we are having water. Now we'll go to the boundary conditions. So click on the axis. So it is selected at axis, then inlet. So at inlet we have to provide the velocity. So velocity is 0.000025 meter per second, and click on the apply. And outlet is pressure outlet, so you need to do nothing in this boundary condition. Okay, and then this is wall. Again, we do not need anything. Now there is no dynamic meshing, so we can leave all these things and we can go to the methods. So again, we can select the default methods. Then we have to go the monitors and click on the residual. Okay, so here the by default the value of residual is 10 raised to the power minus 3. So let us increase this 1 2 3. Okay, 1 2 3 and 1 2. So now that minus 6 is the value, so that will be good. Then click on the OK. Now go to the initialization. So you can select any initialization. So let us select the standard one, and you can compute from say the inlet and initialize it. Okay, and now it is to run the calculations. Okay, so go to the run calculations, and we need to put some iterations. So say 100 iterations, and reporting interval we can select 10 and just click on the calculate. So you can see the value of residuals here. So calculation is completed quite fast. Let us perform some more iterations. Okay. So now the iterations are going on, and you can see here how is your solution is proceeding. So we have 80%, and now we have the 100% solution. So this is how you can perform the solution, and now we will see the some results. Okay, so for that what we can do, we can go to the contours, we can see the contour plots, and we can also see some XY type of plots. So for going to the contour plots, we can click on graphics. So in graphic you can see multiple options. So let us click on the contour. So there are pressure values coming up. So let us see pressure contours. So these are our pressure contours. Okay, now let us click on the velocity contour. So these are our velocity contours. So as you can see, the velocity is maximum at the center, which is the case for pipe flow. In pipe flow, the velocity is usually higher in the center. Okay, you can increase the size also, and near the wall the velocity is 0. Okay, so that we can see that our results are quite good. Okay, and we can see vectors also. So just click on the vectors. So you can see the velocity vectors, how velocity is moving up. Okay, now if you want some plots, so you can click on the XY plot. Okay, and you can select the axis, and you can select the velocity here and just click. So you can see how velocity is changing along the axial direction. Okay, and you can also change the, simply click on the curve and you can select different type of markers. for representing your velocity. Okay. You can also change the color, and there are multiple options which you can use. Okay. And you can also save this. You can also take the snapshots of this for your results. So this is how you can perform the simulation of laminar flow in a pipe. This is one of the basic tutorials. So I have taken minimal options so that you can perform it easily. And this is in fact the first tutorial, and in the coming videos I will be coming up with more complex tutorials so that you can learn the ANSYS Fluent and can solve some real world problems. Till then, have a nice day, and if you like the video, then please subscribe, and please click on the bell icon so that my video